now I'm going to do an example where we only have one angle. You're going to see that some interesting things can happen when we only have one angle. So I'm going to first begin by labeling what we already know. So we already know that alpha is 35. We know that the side opposite alpha, or A, is 6. We also know the side opposite beta, which must be B, is 8. And now our goal is to find beta, gamma, and C. So let me just get my eraser here, making it messy. So I can't, I only have one angle, so I can't use that, the sum of my angles is equal to 180 degrees step right now. But what I can do is I can set up ratios and I can solve for beta. So I'm going to set up my first ratio. I'm going to decide to use A inside alpha and B inside beta because it has what I'm looking for. And also, since I'm looking for beta, I'm going to go ahead and use the inverse. So remember, we can always, or not the inverse, the reciprocal. So we can also say the reciprocals are equal to each other as well. So I'm going to put my angles on top just to be strategic. So sine alpha over A is equal to the sine of beta over B. Let me just get this out of the way. And now I'm going to get beta by itself. So that means I'm going to multiply both sides by B. So, and that'll give me at least my sine beta by itself. I still have to work a little more. So sine beta is equal to B times sine alpha over A. Make that a little longer. And now I need to get B beta by itself. So I can take the inverse sine of both sides. And that will give me, let me just put beta is equal to the inverse sine of all of this. So I have a sine instead of an inverse sine. It's starting to look very pretty, right? Sine of alpha over A. And now I can substitute my numbers to find my angle. So I substituted my numbers. I put this into my calculator. My calculator gave me that beta is equal to 49.9. However, recall that I warned you to be careful with calculators and trig functions because we know that there could be multiple solutions. So this is just going to give me the answer in the first quadrant. I know when it comes to sine, I have, when I'm taking that inverse sine, I can also have an equivalent answer also in my second quadrant, right? So it's giving me information here. That's a really bad quadrant. But I know there's also information on this side too. And I get that other angle by subtracting this angle the calculator gives me from 180. So I know beta can be 49.9 or 180 minus, right, 49.9, which is equal to 130.1. So what is this? So this is letting me know there's actually two possible triangles that can satisfy these conditions. So what I'm going to need to do is I can keep this information here, but I know I could take this one at a time. So I'm going to actually have two problems in one. I'm going to have to solve the triangle assuming, okay, beta is 49.9, and then I can see what my other values are. And then I'm going to have to solve it again, assuming that the angle is 130.1. So what I did is I just set up two conditions, right? Because I have triangle number one when we have beta is equal to 49.9, my first answer, or triangle number two where beta is equal to 130.1, my second. So now that we have everything set up, we can start working on our other values. So the gamma and the C. Gamma is actually, right now it's easier because I have two angles in my triangle. I just need to subtract. If I add these together and subtract it from 180, I can get my third angle. So for my first triangle right here, we can go ahead and set it up. So I'm going to switch over to my pen and I'm going to put gamma, right? We're going to use our favorite little rule. Gamma is 180 minus 35 minus 49.9. And that's going to give us, let me see, 180. So minus 35 minus 49.1, that gives us, in this case, 95.1. So now we have our missing angle. And on this side, we can do the same thing. So gamma is equal to 180 minus 35 minus 130.1. So this is equal to, and that's a really bad gamma. I'm horrible at gammas. I don't know why. That's going to give us 15.9 for this triangle. So I'm going to go ahead and change my colors, right, and fill in my new calculated value. So this is 95.1, and this is 15.9. And now we can use another law of sines ratio in order to find our C in both triangles. So again, I like to use the ratio that contains A and sine alpha because that was like our original information. And then I compare that with or set it equal to C over sine gamma to find that missing side. And since C is on the top and I'm interested in that, I'm not going to worry about taking a reciprocal in this case. So I'm going to go ahead and set up the ratios and solve for C for both of my triangles. So I went ahead and set up the ratio I saw for C, and now I just need to substitute the values from each of my sets into this expression. One nice thing is when you solve in terms of variables, I don't have to keep doing it. I just substitute the information from triangle 1 to get my C for triangle 1, and I substitute my information for triangle 2 to get my C for triangle 2. So now I'm showing the final substitution. Also made a little correction. I realized this was 14.9 and not, I can make that correction up here too, not 15.9. So I did a little typo or I'm not typing, I guess a writing error. So this is 14.9. When I do that, I found for my first triangle, when my beta was 49.9, I found that C was 10.4. And for my second triangle, when my beta was 130.1, I found that C was 2.7. And I'm just going to put circle around these two answers. So this is a little more complicated than before, but we figured it out. Just like a missing puzzle, we noticed, realized that because sine can give us two different answers, right? Or the inverse sine can give us two different answers or multiple answers, that we're going to have multiple triangles that can satisfy these initial two conditions. So now what you're going to do is you're going to go through this again on your own. So you're going to try out this problem right here. So I gave you another triangle. So we have only one angle and we have two side lengths. And what I want you to do is to solve the triangle. So as before, we're going to do some inverse sines. Inverse sines, it could lead to multiple solutions, right, between 180, 0, and 180 degrees. So we have to just keep that in mind when coming up with our final answer. So this is my final answer. So notice that here I set up the ratios, right? I filled in everything that I had so far. I set up the ratio so that I can set sine B over sine beta equal to sine C over sine gamma, just because I had this information. I was looking for beta. I found beta by getting beta by itself. So I did show all the steps. So this is the final equation to get beta by itself. And I substituted the values in. And I found that beta could be either equal to 48.3 or 180 minus 48.3, 131.7. So I set up my two triangles over here. And now that I had my two angles, 85 and 131.7, or 85 and 48.3, I was able to find the third angle by subtracting the sum of the two angles that I already knew from 180. So in my first triangle, that gave me 46.7. So I wrote that here. In my second triangle, it gave me negative 30.7. And that's impossible. We can't have a triangle with a negative angle. So this one is no good. So we really only have one solution or a triangle that solves this problem. But I keep going, so I have everything but A, so I can get A using the law of sines one more time. So A over sine alpha is equal to C over sine gamma. I get A by itself and substitute in all my values, and I finally get that A is equal to 8.8. So here's a situation where, although, sine does give us two possible numbers, once when we investigate a little further and try to calculate that third angle, sometimes it may come up negative. And because this is geometry, and the angles can't be negative in a triangle, sometimes we may only have one solution. And we saw that one solution happen in that very first example as well. So I hope this helps. We're going to do many more problems like this, but the more you do it, the more you'll get comfortable with it.